0.64 and we are taking the first data point. In the first data point, these are actual values, okay? Actual values. We are going to apply this in order to identify the predicted value, right? So predicted value here, x value is 0, weight value is 0.5, okay? So we are taking 0.5 plus 0. Intercept we are taking as 0. So initially we are getting a value, right? This is nothing but predicted output. Predicted output. So actual output minus predicted output is the loss or error. That is what we will be doing in the multi-layer perceptron problem, right? You will be computing actual output y. Then you will be having a target output in the question problem statement. You will be taking the difference between the target output and actual output. That is the error. Right? We have to reduce the error or increase the error. Reduce the error, right? When you reduce the error, our model accuracy will become more. So that's what wherever you are creating a machine learning or deep learning or neural network model, your accuracy should be large. Your accuracy should be large in the sense we have to reduce the error. That error terminology we are calling this here as residuals. Okay, we have many kinds of error. Mean square error. Am I right? Root mean square error. In AML paper itself we have seen, right? MSc, RMSc, root mean square error. Likewise here, sum of squared residuals, sum of squared errors has to be taken to solve the problem. Right? So this is nothing but our actual value. 1.4 is the actual height. This is what you are going to predicted height. We are applying the formula. Predicted height is equal to slope into weight plus intercept. So intercept plus slope value is 0.64 into weight. So weight value for the first one is given here 0.5. Weight is actual height. Actual height is 1.4 applied here. Actual minus predicted one. For prediction, this is the formula. Y equal to ax plus b. That is what we are doing. A into x is the weight value plus b is the intercept value. Here first we are taking intercept as it is. Okay. Likewise, 3 data points are there, right? This is our first data point, second data point. For the second data point, what is the actual height value? 1.9. Weight value is 2.3. So actual height minus 1.9 minus predicted height formula is ax plus b. That is intercept plus slope value is 0.64 into weight. For the second data point, our weight value is 2.3. So you have to apply 2.3 here. Whole square, because this is sum of squared error. Squared error, that's why you have to take the squares. Right? Square plus third data point. Third data point is 3.2 comma 2.9. Actual height is 3.2. So actual, always the formula is actual minus predicted. For prediction, you are having this formula. That is nothing but ax plus b, which is very simple, right? Normal linear equation formula. So 3.2 minus intercept plus slope value is 0.64 into what is the weight value for third data point? Third data point value is 2.9. 2.9 whole square. Okay? You are just applying the actual height value, actual weight value and slope value. Got it? This is the first step. Okay? Now we are going to use You are going to derive next step. So d by d intercept of. So based on the intercept values only, we can able to get the gradient. Okay. So your first will apply intercept is equal to 0. Then next intercept has to be find out. After finding out the next intercept value, you have to apply that intercept value. In the next step, new intercept value has to be find out. Likewise, new intercept has to be find out in each and every step. Alright. So derivative of sum of squared error is equal to d by d intercept of. Based on the intercept only values changes, right? So d by d intercept. Okay, you are just adding derivative only. D by d intercept of same thing. D by d intercept of second data point. D by d intercept of third data point. That is what we meant here. Okay. So in order to solve this derivative, apply chain rule. You based on the chain rule, this square can be multiplied. So 2 into this value into -1 based on chain rule. Okay. So 2 into the complete terminology, complete value for predicting the height. This is what predicting, right? Predicting the height into -1. So when you apply this minus 2 into prediction of height. So this one is for first one. I mean, right? Minus 2 into 1.4 minus I is nothing but intercept plus 0.64 into 0.5. Derivative. Okay. For derivation, this square will be multiplied into -1. That is the application of chain rule here. Okay. So apply the chain rule to second data point. So that second data point will become -2 into 1.9 minus I plus 0.64 into 2.3. Am I right? Apply the rule to third data point. Now tell me, -2 into 3.2 minus I plus 0.64 into 2.9. Got it? Shall I repeat? Are you clear? Are you clear? Second bench. Avantika. Shall I repeat? Yes, once more. Listen. Listen carefully. Options, are you clear about this? Girls, boys, are you clear about this? We are just applying the formula y is equal to ax plus b for prediction. We are going to predict height. Okay? Keep in mind, listen. Keep in mind, you are going to predict height. Y axis is height. X axis is weight. We have 3 different data points here. Each one is having actual height value, actual weight value, which is given here. Okay, which is given here. Are you clear about this actual height and actual weight? You are going to predict, right? For prediction, the formula is ax plus b. Okay, for normally the linear equation is y is equal to ax plus b. In our terminology, now we are going to redefine this a and ax plus b as a is nothing but slope. Slope into weight plus b is intercept. Clear? part. Okay. For second data point, actual part. For third data point, actual part. Until this clear, right? Clear, right? Now go to predicted part. Prediction. Prediction for first data point. Okay. First data point. How can we redefine this? Y equal to ax plus b, right? So in slope value taken in the problem statement is 0.64 for all the data points. Okay. 0.64 into a finish. X. What is x? Huh? Weight value is 0.5 for first data point. So 0.5 plus intercept value we are first taking as I itself. I intercept. We are using with the variable intercept or small I. Okay. Later we will apply value for intercept. Until this clear. Clear. So intercept plus 0.64 into 0.5. This is squared residual. So actual minus predicted height whole square. This line is for first data point. That is this data point. Okay. We have how many data points are there? 3 data points. So move on to second data point. For second data point, actual height is always the formula is actual minus predicted whole square. Okay, because squared here is squared residual. So actual is 1.9 minus same thing intercept plus 0.64. Weight only changes, right? Weight value is 2.3. So 2.3 whole square. Okay. Clear? Last page. Next, third data point. Again formula. Squared residual error equal to actual minus predicted whole square. Actual value given is 3.2. 3.2 minus same intercept plus 0.64 into what is the weight value given in the third data point? 2.9. 2.9 whole square. Until this clear, right? Are you clear? Everyone? So we have to apply derivative for getting the gradient. Okay. So based on the intercept value only we can able to derive the gradient. So take d divided by d intercept. So d by d intercept for sum of squared residual is equal to apply the derivative d by d intercept of first data point. The same thing I have written here. First data point 1.4 minus I is for nothing but intercept plus 0.64 into 0.5 whole square plus d by d intercept of second data point plus d by d intercept of third data point. Clear? Clear until this? Right? So in order to get the value, we can able to apply the chain rule. The chain rule says if you have square here, you can able to multiply this square 2 value with the original value. So 2 into this part, that is 1.4 minus I plus 0.64 into 0.5 into for this derivative into minus 1. That is the formula to derive output. Got it? So this square can be multiplied here into minus 1. We can rewrite this as boys. We can rewrite this as minus 2. This minus 2 comes here, right? Minus 2. 1.4 minus I plus 0.64 into 0.5. This is for first data point. Am I right? So d by d intercept of sum of squared residual is equal to first data point modification plus second data point. Apply the same rule for second data point. Then you can get 2 into 1.9 minus I plus 0.64 into 2.3, right? Into minus 1. So you will be getting this value. Am I right? Right? For third data point. Again 2 into 3.2 minus I plus 0.64 into 2.9 into yes minus 1. So you will be getting this value, right? So this is we are deriving, right? Now apply intercept is equal to 0 for first step. Okay, first step I is equal to 0, intercept is equal to 0. If you apply this I is equal to 0, you will be getting applying this to this step. So if you are applying I is equal to 0, you will be getting the value of minus 5.7. Okay, for I is equal to 0. Okay, I is equal to 0 minus 5.7. But you are going to find out, listen carefully here, you have to find out the next intercept value. At initial stage, we are applying I equal to 0. In the next stage, because I value only changes, right? Other values we have. Am I right or not? Weight we have, slope we have, and everything we have other than the intercept value. In the first step, we are applying I equal to 0. Now we are going to find out the next intercept value, new intercept value. For that, step size is needed. The formula for finding out new intercept is equal to old intercept value minus step size. Okay, step size can be obtained using the result of the first intercept into learning rate. Learning rate will be given in the problem statement. You know it, right? This is what learning rate. In the problem we have solved many problems, right? Learning rate is a constant. Learning rate will be given. So into learning rate. So minus 5.7 into 0.1. That is you are getting minus 0.57. That is step size. Okay. So old intercept value minus step size. Old intercept value taken is I equal to 0 at first. So 0 minus 0.57. So you are getting new intercept value is 0.57. Now what we have to do? So by using this 0.57 value, apply here instead of 0. Now 0.57 has to be substituted. If you substitute 0.57, you will be getting one value, right? Here you will be getting one value, right? Then again find out step size. Okay, step size. Then apply this to new intercept. Suppose you are getting 0.89. Now we have to do apply new intercept value to this equation. You will be getting again new intercept value. When can we stop this intercept? If the difference is less than 0.001, we can able to stop. Until we have to continue the problem. Got it? When can we stop? The difference is equal to 0.00. Which difference? Here first intercept is 0. Second intercept is 0.57. The difference is 0.57, right? So next is we are taking 0.89. Now the difference between 0.89 and 0.57 you have to take whether you are getting less than 0 point, you will be getting values like this. When from closer, you will be getting residual errors like this. This at a particular point, the value, the difference become less than 0.001. At the time we have to stop. Got it? Clear now? Clear? Right? Take it fast. So, as we discussed in the previous classes, we have linearity and non-linearity concept, right? So, in the previous problem, we are solving for linearity, right? So, we have, as we are getting the sum of squared residual, you are getting a curve like this. Am I right or not? You are getting a curve like this, right? So, first I value is equal to 0 means you are getting a value. The first point. I value is next I value is 0.57, right? Applying 0.57, you are getting next value. So, next value data point. Likewise, you are pointing out, you will be getting a curve like this for linear problem. But the thing is, if you are having a non-linear problem, you cannot able to get curve like this. So, you cannot have a curve like this. So, all the things will be, you can have different, this is nothing but minimum point for this whole slope. This is the minimum point, right? So, global minimum point. But for non-linearity problem, we cannot able to get the global minimum points. Rather than you will be getting a small local minimum points. You are getting minimum and then again maximum, then minimum, maximum. Likewise, you will be getting that. So this is for non-linearity and this is for linearity. You cannot get like linearity. So for this only, we are, in order to solve this only, we are moving for neural network. We are going to use neural network. One of the strategy that will work out to solve this kind of non-linear problem is backpropagation algorithm. By computing the gradient using backpropagation algorithm, we can able to solve these kind of non-linearity problems. Okay, so normally linear problem means we can able to take initial feed-forward, a simple feed-forward network. You will be taking a small weight values initial and also small bias values. By computing this, you will be getting one error value. Then after finding out the new intercept, you will be getting a next error value. Likewise, you will be getting a curve structure, right, for linear problem. It is not like that in non-linearity. You are having multiple minimas, right? So that's why one of the best approach is computing gradient using backpropagation algorithm. That is one of the methodology for solving this kind of non-linearity problem. In order to apply this, in order to compute gradient, 3 steps are very important. Okay, so this is for applying gradient. Okay, based on the gradient only, we can able to solve this non-linearity problem. Got it? Using backpropagation algorithm. In order to compute the gradient, 3 steps are very important. First one is choosing the cost function. I told you, right, many cost functions are there. In the previous example, we have seen sum of squared residuals. Instead of squared, we can have sum of residuals. Sum of squared residuals. Likewise, different mean value can also be taken. Right? So different cost functions are available. So choosing the cost function is one of the important points. Next is choosing the form of output unit. We are going to see this elaborately, each and every point elaborately, right? First one is cost function, second is output unit, third one is choosing the optimizer, right? So let us move on to the first step, that is choosing cost function. So normally for any kind of neural network, in order to train the model, the common one which is used is maximum likelihood predicted